Hello everyone. On today's video I will show you how to adjust valve clearances and how to set the timing in our engines. So first of all we need to measure what is the clearance on intake lobes as well as on uh, valve exhaust valves where the rocker works. As you can see I have a pre-assembled timing, which means that that sprocket with chain is already, let's say, on the cam, but it is still loose. Here you can see that I have some problems with setting the cam, but it is caused by the decompensator, which is working. And as you can see, while I put the leverage down, the lobes are in the good position. So generally, uh, clearances has to be measured have to be measured while uh, timing chain is have applied tension on it. So I'm doing it manually, and from the manual we can see that the intake valve clearances have to be somewhere around 0.07 to 0.12 millimeters. Uh, from my experience, it is better to set the clearance nearer top value, so around 10, 12 is better rather than 7, 8. This is because the valves in S6 in our engines have tendency to uh, tightening. So during the normal usage, after a few thousand kilometers, if you put mm, the clearance in in the lower value, it might go out of the range. Okay, so next thing is that what I found is that shims they have the same diameter for intake and for exhaust, but they have a different thickness. I know that each valve can have different thickness, but generally the difference is bigger than you can expect. When you're not sure, for example, you have just installed the new DLC caps, DLC buckets, and you are not sure what shim to pick for the first measurement, I suggest you to go with some low value. For example, for example, for intake valves, I like to use 1.65 or 1.7 shims, and for exhaust, I like to start with uh, 195 or even 2.00. Of course, usually those shims are too thin, and you have to replace them with thicker ones. But it is uh, it is better to use the first measurement to use the uh, thinner shim rather than to have this shim too thick, because then you will have additional work to do to switch to the shim which can be measured. So those are the values. Usually, what I found in those engines, intake shims are around 185 and exhaust around 2.25 or something near that area. Okay, as you can see, I have a tool which is called micrometer, which allows you to measure thickness of, for example, shims with a good precision up to one hundredths of millimeters. Okay, now I'm just using some magnet, but it's not gonna work. I'm gonna use the screwdriver probably. Okay. One more tip. While you install new shims on which you can see the numbers, which actually it's a thickness of shim, it is better to install it with with this sign or numbers facing up. This is because some valves are working in the engine. They are rotating a little bit, and while this those numbers are facing the valve, those will just disappear from scratches. So it is better to install them facing towards. Okay, sorry you can see my measurement, but you need to trust me. Now rocker is going to its original place. Final measurements. I didn't say about exhaust valves clearance. It has to be something between 0.17 and 0.22 millimeters. So basically the same the same stuff as with intake valves. I like to set them in the higher value next to the edge, like 0.20 to 0.22. Now you cannot see the numbers on those plates, which are which you have to use to measure. One more thing, that if you buy the standard uh, those plates to measure intake valves, they will probably have not enough uh, precision uh, precision to measure our clearances. You need to equip yourself with dedicated motorcycle thickness plates. They are they have a smaller scale compared to automobiles like cars or trucks. Okay, now I need to rotate the engine, so it's the front piston needs to go up to the highest position. As you can see, I already locked the cam. It can be done later, but it's already prepared. Here you can see that I'm using the small screwdriver, which goes uh, into the uh, place where spark plug should go, and I'm just feeling if the front piston is on the top position. It will force screwdriver to go a little bit up. Of course, I'm not using any special force to not scratch or damage anything internals. It is almost there. And now, as you can see, I will unscrew the bolt, which is used to set up a proper crank position. While this is unscrewed, you will see that on the crank there are two small holes in which uh, the small drill should go. There is a special Aprilia tool, but I made my own. I don't remember what I was doing there. Uh, okay, I understand now. I'm just putting the lock for this for the rocker, so it won't like lock like this Tiger ring, so it doesn't fall out. Okay, now it's on its place and it's secured. Now you can see my tool, which is a regular bolt with hole inside. It was made on lathe machine. I'm not sure how to pronounce it. So it has to be done with a good precision. It cannot be just drilled by drill on the bench. Okay, so that's important. So while this bolt this screw is on, the drill can go to the in it, and now we need to rotate crank a little bit in the area where the top position of front cylinder is, and we'll be able to push the drill a little bit further and lock crank. You will see in a second. Okay, now the nut came loose because it's a reverse thread, so I'm just gonna use a little bit of force to secure it. You need to be very careful to not break anything. Okay, now I can just move it around again. If you're not sure where you are, you can just unscrew the bolt, and look at the crank, and you will see a small hole inside. As you can see, I just um, I just locked it. So the position is right now fine. So while torquing down the cam, you need to uh, set lobes to face rocker on the front cylinder. I like to uh, put force to to top on the lobes, and down to the sprocket. Remember that on a front cam the thread is reversed. There's not much big difference, but it's better to okay, check in manual what is the force needed to secure it. I think it was something around 30 newton meters, but it's always better to check. Of course, remember to degrease all area where the shaft goes on the cam. It has to be dry and clean. So the first cylinder is done. Now we need to rotate engine for about 270 degrees. So the second piston is has the top position. And one more thing, don't use this bolt uh, with with uh, with drill for securing the crank position. It is only for marking position, not for locking the crank. So do not use any force while it's locked by this drill. Okay, now the rear cylinder is locked. We can start setting timing on the rear cylinder. As you can see on the rear cylinder, the lobes of cam has to face in the other direction. Uh, so it has to face the front cylinder. So we need to lock cam as well with some 6 millimeter bolt. I'm using the drill because it's the same. In here we can see that there's normal thread, so we can just apply. Okay, and that's it.